Welcome to EPG Pathshala. Dear students, today's module is about air masses and fronts. In this module, we are going to discuss about the air mass and its origin, the conventional nomenclature system of air mass, what is front and how it forms, how to differentiate among different types of front, and also to get an idea about the air mass front and their impact on weather. Let's start with air mass. What is air mass? Air mass is a body of air with fairly homogeneous characteristics extending over a large area, that is more than 1000 km, across the surface of the earth and extending to few kilometers above the earth's surface. An air mass is generally characterized by its temperature, moisture, that is humidity, and lapse rate, which is fairly homogeneous and changes only gradually in horizontal and vertical scale. The characteristics of air mass are conserved because the air is stable and stagnant with very less turbulence that restricts the mixing. Air mass is an integral part of the global planetary wind system. What are the sources of this air mass? Air masses form over large homogeneous surfaces like vast ocean surface or vast plains and plateaus with very little or no terrain variation. The source regions have general divergent air circulation, that it has high pressure anticyclonic situation which prevails for several days. Low wind speeds let air remain stationary long enough to take on the features of the source region. The major source regions are warm tropical and subtropical oceans, subtropical hot deserts, relatively cold high latitude oceans, very cold snow covered continents in high latitudes, permanently ice covered continents in the Arctic and Antarctica. Let's see the conservation of characteristics of an air mass. The source region establishes heat and moisture equilibrium with the overlying air mass. When an air mass moves away from a source region, the upper level maintains the physical characteristics for a long period. This is possible because air masses are stable with stagnant air which do not facilitate convection. Conduction and radiation in such stagnant air is also not effective. Let's see the classification of air mass. According to their source region, Arctic or Antarctic air mass, it forms in the Arctic or Antarctic region and are very cold. The second one is the tropical air mass. It forms in low latitude areas and are moderately warm. Third one is polar air mass that take shape in high latitude regions and are cold. Equatorial air mass which develop near the equator and are warm. Based on whether they form over the land or over the water, they are classified as maritime air mass and the continental air mass. Maritime air mass form over the water and are humid. Continental air mass form over the land and are dry. Very often these air masses are identified by the type of clouds within them, like cold air mass and warm air mass. The cold air mass usually show cumuliform clouds, warm air mass contains stratiform clouds. Let's see how the air mass is given the nomenclature. Air masses are classified on weather maps using 2 or 3 letters. The first letter, which is lowercase letter, that describes the amount of moisture in the air mass. For example, M denotes the maritime air mass, that is moist, that forms over the oceanic region. C denotes the continental, dry, that forms over the land mass. And the second letter, which is uppercase letter, describing the geographic origin or the source region, like E equatorial, T for the tropical, P for polar, A for Arctic or Antarctic, S for superior. The situation with dry air formed by a powerful downward motion in the atmosphere leading to adiabatic drying and warming of air mass. The third letter, which is lowercase letter, that describes the thermodynamic process or the relative warmth or coldness of the air mass. Small letter K, that is air mass is colder than the ground below. W, which is air mass is warmer than the ground below. However, in most cases this air mass is represented by its first 2 letters and sometimes only the middle letter only. Let's see some of the examples of such typical types of air mass. For example, CAK, where C small letter, A capital and K small letter. It denotes the continental Arctic air that is colder than the surface over which it lies. MAK, which denotes maritime Arctic air that is colder than the surface over which it lies. CPK, the continental polar air that is colder than the surface over which it is moving. MPK, maritime polar air that is colder than the surface over which it is moving. MTW, maritime tropical air that is warmer than the surface over which it is moving. CTW, continental tropical air that is warmer than the surface over which it is moving. EK, the capital E and small k, the maritime equatorial air that is colder than the surface over which it is moving. EW, maritime equatorial air that is warmer than the surface over which it is moving. This figure shows the popular types of air masses with their source regions. What are the impact of this air mass? It carries the atmospheric moisture from oceans to continents and cause precipitation over land masses. Transport latent heat, thus removing the latitudinal heat balance developed by differential insolation. The cyclones and storms originate at frontal zone between different air masses. Each type of air mass has a typical weather condition associated with it. Continental polar air mass is characterized by dry, cold and stable condition. Maritime polar air masses are cool, moist and unstable one. Air mass are modified by different factors or parameters like temperature and moisture. The underlying surface, that is over which the air mass moves, it modifies the temperature, the moisture condition and stability of the air mass. When the warm tropical air mass moves over a colder surface, the cold surface cools the lower layers of the air mass and increases the stability. The condensation occurs in the form of fog or low stratus cloud. The second factor is topography of the surface. On the windward side of the mountain, there is removal of moisture through precipitation with a decrease in stability. On the leeward side, as the air descends, the stability increases and the air becomes warmer and drier. The third one is the trajectory of the air mass. In case of cyclonic trajectory, the air mass stability in the upper level is decreased as a reflection of the cyclonic relative vorticity. If the trajectory is anticyclonic, its stability in the upper level is increased as a result of subsidence associated with anticyclonic relative vorticity. So far we have seen the air masses. Now we will see about the front. Front is a zone of transition between two air masses of different density and temperature and is associated with major weather changes. This front almost invariably separates air masses of different temperatures, as the temperature distribution is the most important regulator of atmospheric density. Frontal zone is characterized by significant density and temperature gradient. What is frontogenesis and what is frontolysis? When new fronts are created or old fronts are regenerated, it is called frontogenesis and frontolysis. Frontogenesis, it is a slow and gradual process. The wind flow is close, isothermal and flowing from cold air to warmer air. Frontogenesis takes place only when two conditions are met. Two air masses of different densities must exist adjacent to one another. A prevailing wind field must exist to bring them together. And the dying of a front is called frontolysis. Frontolysis must happen for quite some time to destroy the existing front. It occurs when fronts move into the region of divergent airflow. How to classify the front? A front is classified by determining the instantaneous movement. The direction of movement of the front for the past 3 to 6 hours is used for that. The classification is based on the movement relative to the warm and cold air mass involved. The fronts are classified into cold front, warm front, stationary front and occluded front. Again, the occluded front are subdivided into cold occluded front and warm occluded front. Let's see these types of fronts in detail. Cold front. A cold front is defined as the transition zone where a cold air mass is replacing a warmer air mass. The leading edge of the cold air mass typically has a shape like a dome. The cold fronts generally move from northwest to southeast in the northern hemisphere. The air behind a cold front is noticeably colder and drier than the air ahead of it. When a cold front passes through, the temperature can drop more than 15 degrees within first hour. There is typically a noticeable temperature change from one side of a cold front to the other. An abrupt temperature change over a short distance is a good indicator that a front is located somewhere in between. And the typical features of a cold front are the cold air is advancing with time, replacing warm air in the frontal zone. The cold fronts form a steep slope, typically 1:100. Frontal surface is located at the leading edge of the strong temperature gradient. Frontal zone is characterized with a strong dew point gradient and a pressure trough. The pressure drops as the front approaches and rises after it passes. There is a sharp wind shift generally occurs from winds with southerly component to winds with westerly or northwesterly component will occur at the front. Northwesterly winds are generally observed behind a cold front and southwesterly in ahead of it. Cold fronts are indicative of heavy precipitation events, rainfall or snow, which combine with rapid temperature drops. Precipitation may be behind, along or ahead of front, or may not be present, but when present, it will be organized along a line. They move faster than the warm front up to 30 miles per hour, that is about 50 km per hour. And this figure, symbolically a cold front is represented by a solid line with triangles along the front pointing towards the warmer air and in the direction of movement. On the colored weather maps, a cold front is drawn with a solid blue line. The second type is the warm front. A warm front is defined as the transition zone where a warm air mass is replacing a cold air mass. Warm fronts generally move from southwest to the northeast, and the air behind a warm front is warmer and more moist than the air ahead of it. When a warm front passes through, the air becomes noticeably warmer and more humid than it was before. The warm front is usually much slower than the cold front. And the typical features of warm fronts are: warm air displaces colder air. Warm front forms a light slope, typically 1:200. Warm front moves slower than the cold front. Average velocity is about 20 km per hour. Normally, shallow horizontal stratus clouds and light precipitation occurs. Frontal fogs may occur as falling raindrops evaporate in the colder air near the surface. Sleet and freezing rain may also be formed. The intensity of precipitation depends on stability of the warm air. If the warm air is conditionally unstable, thunderstorms may develop over the warm front. If the warm air is stable, the clouds will be layered. If the temperature in the cold air is freezing or below freezing, ice pellets, snow or freezing rain may occur. In this figure, symbolically a warm front is represented by a solid line with semicircles pointing towards the colder air and in the direction of movement. On colored weather maps, a warm front is drawn with a solid red line. Third type of front is stationary front. These occur between a pair of air masses, that is warm and cold, when neither of air mass is strong enough to replace the other. They tend to remain essentially in the same area for extended periods of time, and waves sometimes propagate along the frontal boundary. Although the boundary is stationary, the air on both sides of the boundary can be moving. With a stationary front, air on the cold side of the front will remain or will always be flowing parallel to the front. A wide variety of weather can be found along a stationary front, but usually clouds, prolonged precipitation and storm rain are found there. Storm trains refer to storm moving over a region in a relatively short period of time and often causing severe rain and flash flood. When there is a lot of water vapor in the warmer air mass, significant amounts of rain or freezing rain can occur. The typical feature of stationary fronts are summarized as: in stationary front, two non-similar air masses remain side by side with neither encroaching upon the other. The cold air on the north side of the front is moving parallel to the front, while warm air to the south moving toward the front and get lifted along the frontal boundary. If the warm air is conditionally unstable, a line of showers and thunderstorms may develop in the warm side of the front. If the warm air is stable, widespread layered clouds may form over the front with rain falling on the cold side of the front. In a weather map, this is shown by an interplaying series of blue spikes pointing one direction and red domes pointing the other. And the other type of front is the occluded front. If a cold front catches up to and overtakes a warm front, the frontal boundary created between the two air masses is called an occluded front, or simply you can say it's an occlusion, which means closed off. Occluded fronts usually form around mature low pressure areas during the process of cyclogenesis when the cold front overtakes a warm front. When this occurs, the warm air is separated or occluded from the cyclone center at the Earth's surface. A developing cyclone typically has a preceding warm front, that is leading edge of warm moist air mass, and a faster moving cold front, that is the leading edge of a colder dry air mass wrapping around the storm. North of the warm front is a mass of cooler air that was in place before the storm even entered the region. As the storm intensifies, the cold front rotates around the storm and catches the warm front. Thus forms an occluded front, which is the boundary that separates the new cold air mass to the west or from the old cool air mass already in place north of the warm front. In this figure, symbolically an occluded front is represented by a solid line with alternating triangles and circles pointing to the direction in which the front is moving. The changes in temperature, dew point temperature and wind direction can occur with the passage of an occluded front. In this map, the temperature ahead, that is east of the front, were reported in the low 40s, while temperatures behind, that is west of the front, were in the 20s and 30s. The lower dew point temperature behind the front indicate the presence of drier air. A noticeable wind shift also occurs across the occluded front. East of the front, winds were reported from the east-southeast, while behind the front, winds were from the west-southwest. Occluded front is of two types, cold occluded and warm occluded. Cold occluded front is that when the air behind the warm front is colder than the air ahead of this. It is also known as cold occlusion. Here, the cold air mass underwrites and lifts off the ground both the warm front and the warm air mass. The frontal passage brings weather similar to that of a cold front. It's heavy, often showery precipitation with wind shifting to west or northwest. Warm occluded front. When the air ahead of the warm front is colder than the air behind the cold front, the milder, lighter air behind the cold front is unable to lift the colder, heavier air off the ground. As a result, the cold front rides piggyback along the sloping warming front. This produces a warm type occluded front or a warm occlusion. The surface weather associated with a warm occlusion is similar to that of a warm front. In this table, you can see the difference between cold front, warm front and occluded front. In the case of winds, the cold front has gusty winds and the direction shifting from south-southwest to west-northwest. In warm front, it's a variable wind. Direction generally shifts from south-southeast to south-southwest. And in the case of occluded front, it has variable wind and the direction generally shifts from southeast to south to west to northwest. In the case of temperature, in cold front there is a sudden drop while front is passing and steadily dropping afterwards. And in the case of warm front, the temperature has a steady rise. And in occluded front, there is a dropping in the cold type occluded and rising in the warm type occluded fronts. In the case of pressure, the cold front has minimum pressure, then sharp rise after the front passes. In the case of warm front, it's usually falling, leveling off while front passes, then slightly rise followed by a fall in the pressure. In the case of occluded front, the pressure is at the low point during the passage of front, usually rises after the front passes. In cold front, the clouds are mostly the cumulonimbus. In warm front, it is stratus type. And in occluded front, the cloud types are nimbostratus and sometimes towering cumulus to cumulonimbus. In the case of precipitation, heavy rain, sometimes with hail, thunder and lightning occurs in the cold front. At warm front, drizzle or sometimes no precipitation. In the case of occluded front, light, moderate or heavy continuous precipitation or showers occur. In the case of the dew point, there is a sharp drop and further lowers as the front passes in the case of cold front. And in warm front, this dew point is steady. In the occluded front, it's usually slight drop, especially if cold occluded. So, to summarize, an air mass is a body of air with fairly homogeneous characteristics extending over a large area, spreading over more than 1000 kilometers across the surface of the earth. The depth may vary from few kilometers to the height of the troposphere. The source region establishes heat and moisture equilibrium with the overlying air mass. Air masses are generally classified according to their moisture content, source region and thermal characteristics. And we have seen it has been denoted by 3 letters, lowercase letter for the moisture characteristic, uppercase for the source region and thermal characteristics. For the third one, the air mass regulates the atmospheric energy balance, and we have seen it influences the weather. The properties of air mass may change remarkably as it moves under the influence of the characteristics of the underlying surface, the trajectory of the motion and the time factor, all of them acting in combination. And we have seen that front is a zone of transition between 2 air mass of different density and temperature and is associated with major weather changes. And the creation of new front is called frontogenesis and degeneration of front is called frontolysis. And we have also seen the classification of fronts as cold front, warm front, stationary front and occluded front. A cold front is a transition zone where a cold air mass is replacing a warmer air mass. And these cold fronts have steep slope with characteristic gusty wind and sudden drop in temperature. These are indicative of heavy precipitation events, rainfall or snow combined with rapid temperature drops. A warm front is the transition zone where a warm air mass is replacing a cold air mass. This front usually moves much slower than cold front and usually forms shallow horizontal stratus clouds and light precipitation. Frontal fogs may occur as falling raindrops evaporate in the colder air. The stationary front occurs between a pair of air masses when neither of air mass is, that is warm and cold, is strong enough to replace the other for extended period of time. These stationary fronts are usually characterized by clouds, prolonged precipitation and storm trains. If a cold front catches up to and overtakes a warm front, the frontal boundary created between the 2 air mass is known as occluded front. These occluded fronts usually form around mature low pressure areas during the process of cyclogenesis when the cold front overtakes a warm front. Occluded fronts are characterized by development of nimbostratus clouds or sometimes towering cumulus to cumulonimbus cloud formation with light, moderate or heavy continuous precipitation. Thank you.